We need to talk about the rock that's coming for us. Not metaphorically, not eventually in some distant future, but actually literally, inevitably. Somewhere in the solar system, right now, there's a piece of stone and metal and ice following an orbit that will, one day, intersect with Earth's orbit at precisely the wrong moment. It's already out there, already moving, already on the trajectory that will bring it here. We just don't know which one it is yet, don't know when the intersection will occur, don't know if we'll see it coming or if it will arrive from the direction of the sun where our telescopes are blind. What we do know is this: it's not a question of if, it's a question of when. Earth has been hit before, many times. The craters are still visible, though most have been eroded, filled in, hidden by vegetation and ocean. Meteor crater in Arizona, Chicxulub in Mexico, Vredefort in South Africa. These are the scars of impacts, the marks left by stones from space that fell at cosmic velocities and released energies that dwarf anything humanity has ever created. The last truly large impact was 66 million years ago. The Chicxulub impactor, a rock roughly 10 kilometers across, struck what is now the Yucatan Peninsula with a force equivalent to 10 billion Hiroshima bombs. The impact triggered earthquakes, tsunamis, global firestorms, and a winter that lasted years. The dinosaurs, which had dominated Earth's ecosystems for 165 million years, were extinct within months. That was 66 million years ago. The average time between extinction-level impacts is estimated at 50 to 100 million years, which means statistically we're not overdue yet, but we're approaching the window. And when the next one comes, when the next Chicxulub-scale impactor arrives, modern civilization will not survive it. We'll have some warning. Probably. If our telescopes spot it years in advance, if it's coming from a direction we're monitoring, if it's large enough to be visible at distance, we might have months or years to prepare to try to deflect it, to evacuate what we can. But deflection is extraordinarily difficult. We've never done it at scale. We have theories, simulations, a few small test missions, but actually changing the trajectory of a mountain-sized rock moving at tens of kilometers per second. That requires technology and coordination we might not achieve in time. An evacuation? Evacuate to where? An impact doesn't just affect the local area. A Chicxulub-scale event affects the entire planet, the atmosphere, the climate, the biosphere. There's nowhere on Earth that's safe from the global consequences, so we're vulnerable, completely vulnerable, to an event we know will occur that has occurred many times in Earth's history. That's simply part of living on a planet in a solar system full of debris left over from its formation. Let's understand what we're facing. Let's map the sequence of destruction that follows an extinction-level impact before we contemplate whether we can survive it. Asteroids are remnants from the solar system's formation 4.6 billion years ago. Most orbit in the asteroid belt between Mars and Jupiter, stable and harmless, but gravitational interactions with Jupiter occasionally perturb these orbits, sending asteroids on trajectories that cross Earth's orbit. These are called near-Earth objects, or NEOs. There are tens of thousands of them, maybe hundreds of thousands, ranging in size from meters to kilometers across. Most are small, harmless, but some, the largest ones, are planet killers. We've catalogued many of them. NASA's Near-Earth Object Program has identified about 90% of the kilometer-plus asteroids whose orbits come near Earth. None of the known ones pose a threat in the next century. Their trajectories have been calculated, their future positions predicted, and they'll miss us. But 90% isn't 100%. There are still large asteroids we haven't found, orbiting in regions we don't monitor constantly, or too dark to see easily, or coming from angles that make detection difficult. And even among the ones we've found, orbital calculations aren't perfect. They depend on knowing the asteroid's mass, composition, shape, rotation. Small errors accumulate over decades. An asteroid predicted to miss Earth by 1 million kilometers might actually miss by only a few thousand, or not miss at all. Then there are comets, long-period comets, coming from the Oort cloud at the edge of the solar system, falling toward the Sun on orbits that take thousands of years to complete. We can't predict these. We can't catalogue them because they're too far away, too dark, invisible until they're already on their way in. When a long-period comet appears, we might have months of warning, or we might have weeks. It depends on when we spot it, how bright it is, how fast it's moving. And comets move fast. They're falling from the outer solar system, accelerating as the Sun's gravity pulls them inward. Impact velocities can exceed 70 kilometers per second. At that speed, kinetic energy is apocalyptic. A 10-kilometer comet hitting Earth at 70 km/s releases about 1024 joules of energy. That's 100 million megatons. That's the entire global nuclear arsenal multiplied by 1,000. One rock, one piece of ice and stone, more destructive than every weapon humanity has ever built. Let's walk through what happens when that rock arrives, second by second, day by day, as Earth experiences its second Chicxulub event. Day 0, T-minus 10 seconds. The asteroid has been falling toward Earth for months or years, accelerating under gravity, growing larger in telescopes, becoming brighter in the sky. Governments have been tracking it, calculating impact coordinates, trying and failing to deflect it. Evacuations have been attempted but are incomplete. Billions of people are watching the sky, knowing what's coming, helpless to stop it. The asteroid is 10 kilometers across, roughly the same size as the one that killed the dinosaurs. It's moving at 30 kilometers per second, not as fast as a comet, but fast enough. Its trajectory will bring it down in the Atlantic Ocean, roughly halfway between Africa and South America. The sky brightens. The asteroid, heated by friction as it plows through the upper atmosphere, is glowing white hot. It looks like a second sun, a star descending from the heavens, growing brighter with each passing second. T-minus 5 seconds. The asteroid reaches the stratosphere. The air in front of it can't get out of the way fast enough. It compresses, heats to thousands of degrees. The asteroid's surface begins to ablate, vaporize, but it's so massive that ablation barely affects it. It's losing tons of material per second, leaving a brilliant trail across the sky, but it's still fundamentally intact. People on ships in the Atlantic have less than 5 seconds to live. Some look up, see the descending star, understand. Others are below deck, unaware. It won't matter. T-minus 1 second. The asteroid punches through the lower atmosphere. The sonic boom is unimaginable, a shockwave that rattles windows on 3 continents. But the sound is irrelevant compared to what's about to happen. T0, impact. The asteroid strikes the Atlantic Ocean at 30 kilometers per second. The kinetic energy release is instantaneous, all 1023 joules unleashed in a fraction of a second. The water doesn't splash, it vaporizes instantly. Billions of tons of seawater flash into superheated steam. The asteroid punches through the water. The ocean is only a few kilometers deep here, barely an obstacle, and strikes the seafloor beneath. Rock vaporizes. The seafloor is pulverized, then vaporized, then converted to plasma. A crater begins forming, expanding outward at supersonic speeds. In the first second, the crater is already 20 kilometers across and still growing. The asteroid itself no longer exists as a solid object. It's been converted to plasma, to vapor, to energy. But its momentum continues, driving the expanding shockwave outward and downward, excavating the seafloor, creating a crater that will eventually be 150 kilometers across and 20 kilometers deep. The energy release creates a fireball that briefly rivals the sun in brightness. This fireball expands upward and outward, breaking through the ocean's surface, rising into the atmosphere as a column of superheated plasma and vaporized rock and water. T plus 10 seconds. The immediate impact zone is annihilated. Everything within 500 kilometers is subjected to thermal radiation, intense enough to ignite trees, to vaporize exposed flesh, to melt metal. Ships in the Atlantic within this radius simply cease to exist. Coastal cities on both sides of the ocean are experiencing a heat flash that ignites everything flammable. But the thermal radiation is just the beginning. The shockwave is propagating outward through the Earth's crust. This is not an earthquake. It's something far more violent. It's a pressure wave travelling at kilometres per second, carrying more energy than the largest earthquakes in recorded history. At T plus 30 seconds, the shockwave reaches the coasts. Buildings collapse instantly. Not from ground shaking, but from the shockwave itself. A wall of overpressure that crushes structures, that turns concrete into dust, that levels cities in seconds, and then comes the ejector. T plus 1 minute. The expanding crater has thrown millions of tons of seafloor and vaporized asteroid into the atmosphere. This material, rock, dust, plasma, is rising on columns of superheated air, reaching altitudes of 100 kilometers or more, above the bulk of the atmosphere. Some of this material is moving fast enough to achieve escape velocity. It will leave Earth entirely, spreading into the solar system. Some will fall back immediately, but much of it, trillions of tons of pulverized rock, will remain suspended in the upper atmosphere, spreading around the globe, blocking sunlight. T plus 5 minutes. The first tsunami is forming. The impact crater has displaced an enormous volume of water. That water is rushing back in, creating waves. But these aren't normal tsunami waves. These are impact-generated mega-tsunamis, with wave heights measured in hundreds of meters. The waves propagate outward in all directions. They'll reach the coasts of Africa and South America within an hour, Brazil and West Africa within 2 hours. Wave heights at the coast will be 300 meters or more, taller than the tallest buildings, carrying enough energy to sweep kilometers inland. Coastal cities on both sides of the Atlantic are doomed, not just damaged, completely destroyed, wiped from existence as if they never were. T plus 1 hour, the fireball has risen into the stratosphere, spreading laterally, forming a mushroom cloud that dwarfs anything from nuclear weapons. The thermal radiation has ignited fires across 2 continents. Forests are burning, cities are burning. The smoke is rising, adding to the ejector already in the upper atmosphere. The shock wave has circled the globe. Every seismograph on Earth is recording off-scale readings. Earthquakes are triggering along fault lines worldwide. Volcanoes are erupting as the pressure wave destabilizes magma chambers, and the mega tsunamis have reached land. The footage, for those who can still broadcast, who still have power, who are far enough from the coast to survive, shows walls of water engulfing cities. Buildings are swept away like toys. Millions of people are dying, drowning, crushed under collapsing structures, or carried inland by the relentless flood. T plus 6 hours. The immediate devastation is complete. The impact site is a boiling crater, still radiating heat, surrounded by concentric rings of destruction. Everything within 1,000 kilometers of the impact is destroyed. Everything within 3,000 kilometers is severely damaged. But the global effects are just beginning. The ejector, the billions of tons of pulverized rock and dust, is spreading through the upper atmosphere. It's forming a layer that's beginning to block sunlight. The amount of material is so vast that even though individual particles are tiny, collectively they're creating a shroud around the entire planet. Earth is beginning to dim. T plus 24 hours, day 1. The sun rises, but you can barely tell. The sky is dark, choked with dust and ash. The impact ejector has spread across the entire northern hemisphere and is moving into the southern hemisphere. Sunlight that normally reaches Earth's surface is being blocked. Not completely, but significantly. Maybe 50% reduction in some areas, 70% in others. The temperature is already dropping. Not catastrophically, not yet, but measurably. A few degrees in the first day. More to come. Fires are still burning from the initial thermal pulse, from the impact's heat. Forests in South America, Central America, parts of Africa, all ablaze. The smoke is adding to the atmospheric opacity, further blocking sunlight, and the casualties are mounting. The immediate death toll from the impact, the shockwave, the mega tsunamis, perhaps 1 billion people, everyone within direct line of sight to the impact fireball. everyone in coastal cities on both sides of the Atlantic, everyone in buildings that collapsed from the seismic shock. But those are just the immediate deaths. The real catastrophe is beginning. Day 7, 1 week after impact. Temperatures have dropped by 10 degrees Celsius globally. In some regions, especially those already in winter, it's much worse, 20 or 30 degree drops. The blocking of sunlight isn't uniform. Some areas get more sunlight through the dust, some less, creating chaotic weather patterns. Storms are constant, global. The atmospheric heating from the impact, the disruption of normal circulation patterns, the temperature gradients between heated and cooled regions, all creating hurricane-force winds, torrential rains, violent weather that makes normal life impossible. Agriculture is failing. Crops need sunlight. With 50–70% reduction, photosynthesis is severely impaired. Plants are growing slowly or not at all. The growing season, wherever it was happening, has effectively ended. Food stockpiles are being depleted. Governments are rationing, trying to make supplies last, but the math is brutal. Most nations have food reserves for weeks or months, not years, and the impact has destroyed major food-producing regions, coastal areas where much of the world's population lives, where intensive agriculture occurs. Infrastructure is collapsing. The tsunamis destroyed ports, shipping, transportation networks. The earthquakes and storms are making land transport difficult or impossible. Global supply chains, already stressed by the impact, are breaking down completely. People are starting to starve, not the immediate survivors of the impact. They're already dead. But the billions who survived the first day, who thought they were safe because they were far from the impact zone, are now facing the slow realization that the global food system has failed. Day 30, 1 month after impact. The temperature has dropped 15–20 degrees Celsius globally. What was summer in the northern hemisphere now feels like autumn. What was winter is now lethal cold, and it's still dropping. The term being used is impact winter, similar to nuclear winter but triggered by an asteroid instead of nuclear weapons. The mechanism is the same: particulates in the stratosphere blocking sunlight, preventing solar heating, causing global temperatures to plummet. Photosynthesis has essentially stopped. Plants can survive reduced light for a while, but not this reduced, not this sustained. Forests are dying. Grasslands are dying. Agricultural crops, those that weren't destroyed by the impact or the cold, are failing. The oceanic, phytoplankton, microscopic organisms that form the base of marine food webs and produce much of Earth's oxygen are dying. They need sunlight too. With the ocean surface darkened, with water temperatures dropping, the phytoplankton populations are crashing. This triggers a cascade. Small fish that eat phytoplankton are starving. Larger fish that eat the small fish are starving. The entire marine food web is collapsing from the bottom up. On land, herbivores are dying from lack of food. The plants they depend on are dead or dormant. Carnivores are dying as their prey disappears. Ecosystems worldwide are experiencing mass die-offs, and humans are dying. The global population, which was 8 billion before the impact, has dropped to perhaps 6 billion. Starvation, cold, disease, violence over remaining resources, the death toll is accelerating. Day 90, 3 months after impact. Global temperatures are down 25–30 degrees Celsius from pre-impact levels. It's winter everywhere. Snow is falling at the equator. The oceans are beginning to freeze at high latitudes. The dust is still in the atmosphere. It's settling slowly, but the lighter particles remain suspended, and the continuous fires, burning forests, burning cities, burning whatever can still burn, are adding new particulates to replace what falls out. The darkness is profound. Even at midday, it's like twilight. The sun, when it's visible through the dust, is a dim red disk. Photosynthesis is negligible. Plants that haven't already died are dormant, waiting for light and warmth that might not return for months or years. The human population has dropped below 4 billion. Those who remain are clustered in areas with some resources, some shelter from the cold. Governments have collapsed or are barely functioning. Law and order are memories. Survival is individual or small group, not societal. Food is gone. The stored reserves ran out weeks ago. People are eating anything: bark, insects, leather, each other. There are reports of cannibalism, of communities turning on themselves in desperation, and the cold continues to deepen. Day 180, 6 months after impact. The temperature has stabilised, sort of. It's dropped as low as it's going to drop, about 30-35 degrees below pre-impact levels. But stabilised doesn't mean recovering. The impact winter is settling in for the long term. The atmosphere is still full of dust. The fires have mostly burned out. There's little left to burn. But the ejecta from the impact is slow to settle. Particles that made it into the stratosphere can remain there for years. Scientists, those who survived and still have access to modelling tools, predict the impact winter will last 5 to 10 years, maybe longer. The exact duration depends on how much material was thrown into the atmosphere, how high it went, what the particle size distribution is, but minimum 5 years of drastically reduced sunlight and temperatures. 5 years. Without agriculture. 5 years of winter. 5 years for the biosphere to collapse and potentially recover, if anything is left to recover. The human population is below 2 billion now, maybe below 1 billion. It's hard to count. Communication networks are long gone. No one has a global view anymore. Isolated communities survive or don't, without knowledge of what's happening elsewhere. Those who remain are hardy, lucky, or both. They've found ways to survive. Geothermal energy, stored food, insulated shelters. Some communities near the equator, where temperatures dropped less dramatically, where some plant life is still clinging to existence, have better odds than those at higher latitudes. But even these survivors are on borrowed time. The stored food will run out. The plants, if they recover at all, will take years to regrow enough to support populations, and there's no guarantee of recovery. Earth's climate has been kicked into a new state, and where it settles is unpredictable. Year 1. 1 year after impact, Earth is a different planet. The temperature is still 30 degrees below normal. Snow covers most continents. The oceans are partially frozen. The sky is still dark with dust, though it's slowly clearing. The human population has stabilised, sort of. Maybe 500 million people remain. Maybe less. The die-off has slowed because most of those who are going to die from starvation and cold have already died. Those who remain are in sustainable situations. Geothermal heated caves in Iceland, equatorial regions with some surviving vegetation, well-prepared bunkers with years of supplies. But this isn't civilization. This is survival. Small, isolated groups, cut off from each other, from technology, from the systems that supported billions. We've regressed to pre-industrial existence, except we lack the knowledge and infrastructure that pre-industrial societies developed over millennia. And we're still not safe. The impact winter will continue for years. When it finally ends, when the dust settles and sunlight returns, the climate will have changed. Ocean currents will have shifted from the temperature changes. Weather patterns will be different. The ecosystems that do recover will be different from those that existed before. Earth will heal. Life will recover. But it will be a different Earth, with different ecosystems, and humanity's place in those ecosystems is uncertain. Let's talk about what we could have done, what we tried to do, because preparation for asteroid impacts is one area where we've actually made some effort, where we've recognised the threat and attempted to develop responses. NASA's Near-Earth Object Program has been cataloguing asteroids since the 1990s. The goal was to find 90% of the kilometre-plus asteroids, the planet killers, and track their orbits to ensure none are on collision courses with Earth. We've largely succeeded. About 90% are catalogued. We know where they are, where. They'll be in the coming decades. None pose imminent threat, but 90% isn't 100%, and imminent is a relative term. An asteroid discovered today might be on a collision course for 50 years from now. That's a lot of warning time, which is good. But it also means we need to maintain tracking. maintain calculations, maintain vigilance for decades, and we need the capability to deflect. Because discovering a threatening asteroid is only useful if we can do something about it. Deflection is theoretically possible. The basic idea is simple. Change the asteroid's velocity slightly, years in advance, so that when it reaches Earth's orbit, Earth isn't there anymore. The asteroid passes through where Earth would have been, missing by thousands or millions of kilometers. The slightly is key. You don't need to move an asteroid far, just enough to change its arrival time by minutes or hours. Earth moves at 30 kilometers in its orbit. If you delay the asteroid's arrival by 1 hour, Earth has moved 108,000 kilometers. That's a clean miss. The challenge is applying force to an asteroid years in advance. Asteroids are massive, millions or billions of tons. They're moving at tens of kilometers per second. Changing their velocity even slightly requires enormous energy. Several methods have been proposed. Kinetic impactor: crash a spacecraft into the asteroid at high speed, transferring momentum. This works for smaller asteroids but becomes impractical for larger ones. You'd need multiple impactors, each requiring years to build and deliver. Gravity tractor: position a spacecraft near the asteroid and use its gravity to slowly pull the asteroid off course. This is elegant and doesn't require touching the asteroid, but it's slow. You'd need decades of warning time. Nuclear detonation: detonate a nuclear weapon near, not on the asteroid, using the X-ray pulse to vaporize surface material. The vaporization creates thrust, pushing the asteroid. This is probably the most effective method for large asteroids, but it's politically complicated and untested. Solar sail: attach a large reflective sail to the asteroid, using sunlight pressure to slowly push it off course. Again, requires decades of warning. Each method has limitations. Each requires years or decades of warning. Each requires international cooperation and massive resources. And none have been tested at the scale needed for a Chicxulub-size impactor. We did test one concept. NASA's DART mission in 2022 successfully altered an asteroid's orbit by crashing a spacecraft into it. The asteroid was small, the deflection was minor, but it proved the concept works. But scaling from a small test asteroid to a 10-kilometer planet killer is non-trivial. We might be able to deflect a kilometer-size asteroid with enough warning. A 10-kilometer asteroid? That's uncertain. And if it's a long-period comet, coming from the outer solar system, discovered only months before impact, we couldn't deflect it. Not with current technology. We could only watch it come. Let's talk about the psychological impact of knowing an asteroid is coming, because in many scenarios, we'd have weeks to months of warning. Time enough to know, to understand, to realize that the end is approaching, and there's nothing we can do. Imagine the announcement. Astronomers have detected an asteroid. It's large, 10 kilometers across. Its trajectory has been calculated. It will hit Earth in 6 months. Impact point is predicted to be the Pacific Ocean. The impact will trigger an extinction-level event. How do people respond to that news? Initially, denial. This can't be real. Asteroids don't hit Earth. Or if they do, we'll deflect it. Scientists will figure something out. Governments will act. There's always a solution. But as the weeks pass, as the asteroid grows brighter in the sky, as every attempt at deflection fails or proves inadequate, denial becomes hard to maintain. Some people turn to religion. If the end is coming, they want to make peace with their gods, want to believe that death is not the end, that consciousness continues in some form beyond the physical destruction of the body and world. Others turn to hedonism. If we only have months, why not experience everything possible? Why not indulge every desire, break every rule, live without consequence because consequences require a future and there is no future? Some become fatalistic. They continue their normal routines, go to work, pay bills, maintain the pretense of ordinary life because what else is there to do? The alternative, acknowledging the approaching doom, is too painful, too overwhelming. and some try to prepare. They stockpile food and water, build shelters, move to remote areas hoping to survive the impact and its aftermath. Most of these preparations are futile. You can't stockpile enough food for years of impact winter, can't build a shelter that will protect you from global ecosystem collapse. But the act of preparing gives a sense of agency, of control, even when control is illusory. Governments try to maintain order, but it's difficult. Why should people follow laws when the world is ending? Why pay taxes? Why go to work? Why do anything except spend your remaining time with the loved ones or pursuing whatever brings you meaning? Some regions collapse into chaos, looting, violence, the breakdown of social order. Others maintain surprising stability. Communities pull together, share resources, support each other through the final months. And all the while, the asteroid grows larger in telescopes, becomes visible to the naked eye, a star that moves against the background of normal stars, growing brighter each night, a visible reminder of the approaching end. The last month is surreal. The asteroid is bright enough to see during the day, a point of light near the sun. People watch it, track it, calculate exactly when and where it will hit. The predictions narrow from somewhere in the Pacific to specific coordinates to a countdown measured in days, then hours. The final day people gather, some with family, some with friends, some with strangers who become companions in the face of shared doom. They watch the sky, waiting for the flash, the shock wave, the end. And when it comes, when the asteroid finally arrives, there's almost a sense of relief. The waiting is over. The uncertainty is resolved. Whatever happens next, at least the anticipation has ended. This is perhaps the cruelest aspect of asteroid impacts. They give us time to know, time to understand, time to experience anticipatory grief for our own deaths and the death of our world, but not enough time to prevent it. Let's shift perspective now. Let's move from the immediate horror of impact to the deeper questions about what it means to live on a planet in a shooting gallery, to build a civilization in a solar system full of debris that occasionally falls to Earth. Asteroid impacts are not rare on cosmic timescales. Earth has been hit thousands of times over its 4.5 billion year history. Most impacts are small, meteorites that burn up in the atmosphere or create small craters. But large impacts, extinction-level events, happen regularly when measured in millions of years. The geological record shows at least 5 major mass extinctions, and asteroid impacts are implicated in several of them. The Cretaceous-Paleocene extinction, 66 million years ago, is the most famous, the one that killed the dinosaurs, but it's not the only one. There are impact craters all over Earth, though most are heavily eroded or buried. Chicxulub in Mexico, Vredefort in South Africa, Sudbury in Canada. Each one marks a moment when a piece of the solar system's debris fell to Earth and changed the planet's history. These impacts aren't malicious. The asteroids aren't aiming at us, aren't trying to destroy us. They're just following orbits determined by gravity and momentum, orbits that occasionally happen to intersect with Earth's orbit at the same time Earth is there. It's purely mechanical, purely probabilistic, and purely inevitable over long enough timescales. This is a different kind of threat than the others we've discussed. Gamma-ray bursts and solar storms come from astronomical processes outside the solar system, or from the sun. They're external, distant, largely beyond our ability to observe until they happen. But asteroids are here, in our neighbourhood, orbiting the same sun we orbit. We can see them, can track them, can potentially do something about them with enough warning and resources. This makes asteroid impacts both more and less terrifying than other cosmic threats. More terrifying because they're local, tangible, happening in our cosmic backyard. Less terrifying because they're the one existential threat we might actually be able to prevent with sufficient effort. The question is whether we'll make that effort, whether we'll invest the resources needed to catalogue every potentially hazardous asteroid, to develop reliable deflection technologies, to maintain the vigilance required to catch threats years or decades before impact. So far we've made some progress. but it's incomplete, underfunded, inconsistent. We know enough to understand the threat, but not enough to guarantee we can prevent the next major impact. And we're running on borrowed time. Every day that passes without an impact is another day we've been lucky, another day the cosmic dice have rolled in our favour. But the dice keep rolling, and eventually our luck will run out. Let's talk about the survivors, because even a Chicxulub scale impact wouldn't kill everyone immediately. Some humans would survive the impact, the tsunamis, the shockwave. They'd face the impact winter, the starvation, the collapse of civilization, and some of them, a small fraction, would survive even that. Who survives? Not randomly. Survival in an impact scenario depends on location, resources, preparation, and luck. Location matters enormously. If you're near the impact site, you're dead. If you're on a coast that gets hit by the mega tsunami, you're dead. If you're in a region that experiences severe earthquakes or volcanic eruptions triggered by the impact, your odds are poor. But if you're inland, away from coasts in a geologically stable area, you survive the immediate effects. Then you face the impact winter. Resources matter. Do you have access to food, to heat, to shelter that can protect you from months or years of winter? Most people don't. Most people depend on global supply chains, on electricity, on infrastructure that will fail within days of a major impact. But some people are positioned better. Those in regions with geothermal energy, Iceland, New Zealand, parts of the western United States, have access to heat and power that doesn't depend on fuel or infrastructure. Those in areas with large food stockpiles, agricultural regions, with grain silos, military installations with supplies, have better odds of surviving the initial starvation period. Preparation helps, but has limits. You can stockpile food and water, can build insulated shelters, can prepare for disruption. But you can't prepare for years of impact winter unless you have industrial-scale resources. Individual preparation might get you through the first months. It won't sustain you through 5 years of darkness and cold, and luck is always a factor. Did the impact trigger volcanic eruptions near you? Did the shifting climate patterns bring unusually severe cold to your region? Did desperate survivors from neighbouring areas raid your supplies? Countless variables, most beyond your control, determine whether you make it through. The survivors would be scattered, isolated, cut off from each other. Without global communications, without transportation networks, they wouldn't know about other survivor groups, wouldn't be able to coordinate or share resources. Each group would face the same challenges: find food, stay warm, maintain morale, survive long enough for the climate to recover and agriculture to become possible again. Some groups would fail, supplies would run out, or the cold would prove too severe, or disease would spread through the confined shelters. Others would succeed, would find ways to produce food despite the darkness, mushroom cultivation perhaps, or raising insects, or hydroponics with geothermal-powered lights. These successful communities would become the seeds of post-impact humanity, small populations genetically bottlenecked, carrying forward whatever knowledge and culture they could preserve. They'd be humanity's ark, the bridge across the impact winter to whatever world emerges on the other side. What would that world look like? Years after the impact, the dust would finally settle, sunlight would return, the temperature would begin to rise, snow would melt, rivers would flow again, and plants would begin to grow. First the hardier species, those that survived as seeds or roots, then gradually more complex ecosystems. But it wouldn't be the same world. The impact and winter would have reshuffled the deck. Species that depended on specific ecosystems, specific food sources, specific climate conditions, many would be extinct. What remained would be the generalists, the hardy, the lucky. Forests would regrow, but different forests. Different species composition, different structure. Grasslands would return, but altered. The oceans would recover, but the marine ecosystems would be changed. Some species gone, others filling the vacant niches, evolving into new forms. And humanity, if we survived at all, we'd be starting over. The survivors would rebuild, but from a vastly reduced population, with limited resources, with much of our accumulated knowledge lost when libraries burned, when servers failed, when the people who held specialised knowledge died, we'd retain some technology, basic metalworking, simple agriculture, perhaps some electronics in hardened systems, but we'd lose much: spaceflight, advanced computing, global communications. The intricate technologies that require global industrial supply chains wouldn't be reproducible by small, isolated survivor communities. We'd be set back centuries, perhaps millennia, and we'd carry the memory of the impact, the knowledge that it happened before and could happen again. That knowledge would shape post-impact civilization in ways we can't predict. Would we be more cautious, more focused on resilience, more committed to preventing future impacts? Or would we be traumatized, risk-averse, unable to rebuild the complex technological civilization that left us vulnerable in the first place? There's no way to know. But the survivors would be different from us, would build different societies, would have different values shaped by the experience of near extinction. Let's talk about prevention in more detail, because unlike most cosmic threats, asteroid impacts are something we could potentially prevent with sufficient effort and resources. The key is early detection. If we know an asteroid is coming years or decades in advance, we have options. We can launch deflection missions, can apply small forces over long periods to gradually shift its orbit, can ensure it misses Earth when it reaches our orbital neighbourhood. But early detection requires comprehensive sky surveys. We need to find every potentially hazardous asteroid, catalogue its orbit, calculate its future trajectory. This is computationally intensive, requires powerful telescopes scanning the sky constantly, requires software to identify new objects and track their movement. We've made progress. NASA's NEOWISE mission, the Catalina Sky Survey, Pan-STARRS, various ground-based telescopes searching for near-Earth objects. Together, they found most of the large asteroids, the kilometre-plus objects that pose extinction-level threat. But most isn't all, and smaller objects, 100 metres across say, can still cause regional catastrophes. The Chelyabinsk meteor in 2013 was only 20 metres across, and its airburst injured over 500 people and damaged thousands of buildings. A 100-metre object hitting a city would kill millions. We need better surveys, more telescopes, more computing power, more international coordination, and we need them continuously. Asteroids can have their orbits changed by gravitational interactions with planets, so an object that was safe decades ago might not be safe now. Then there's deflection technology. We've tested kinetic impactors with the DART mission. It worked on a small asteroid, but we haven't tested nuclear deflection, gravity tractors, or any method at the scale needed for a large asteroid. We should. We should have tested, proven, ready to deploy systems for deflecting asteroids of various sizes. We should have spacecraft designs on the shelf, ready to build and launch quickly if a threat is detected. We should have international agreements on who leads the deflection effort, who pays for it, how decisions are made. We don't have these things. We have proposals, simulations, academic papers, but not operational systems, not proven hardware, not established protocols. This is partly a matter of resources. Asteroid deflection isn't cheap. Developing and testing systems cost billions. Maintaining sky surveys costs millions per year. These are investments in preventing an event that might not happen for decades or centuries. It's also partly a matter of coordination. Asteroids don't respect national boundaries. A deflection effort needs international support, shared costs, agreed upon decision-making. But getting countries to cooperate on long-term projects with uncertain timelines is difficult. So we muddle along, making some progress, finding some asteroids, testing some technologies, but not moving as fast as we should, not investing as much as we should, not taking the threat as seriously as we should. Because it's easy to deprioritize threats that aren't imminent, easy to focus on problems we face today rather than catastrophes we might face decades from now. Easy to assume we'll deal with it when the time comes. But when the time comes, when we detect an asteroid on a collision course, We might not have time to develop and deploy deflection systems. We might have only months or years, not the decades needed to build and test new technologies. And then we'd be in the position of watching helplessly as the asteroid approaches, knowing it will hit, knowing billions will die, knowing we had the ability to prevent this but didn't make the effort when we had the time. Let's think about consciousness again, about what it means to be aware in a universe where rocks from space can end civilizations without warning or malice. You're made of atoms that were forged in stars scattered by supernovae, collected by gravity into planets. Some of those atoms organize themselves into molecules, into cells, into a body with a brain capable of awareness. That organization is temporary. Eventually your atoms will scatter again, will return to the environment, will become part of other structures, other processes. Your consciousness, which depends on the specific configuration of atoms in your brain, will end when that configuration dissolves. Asteroid impacts are just one way the configuration can dissolve. Not the most likely on individual timescales. You're far more likely to die from disease or accident or age. But on civilizational timescales, on evolutionary timescales, asteroid impacts are major disruptors, major resets of the planetary ecosystem. The dinosaurs evolved over 165 million years, achieved enormous diversity, dominated terrestrial ecosystems, and then an asteroid hit, and within months they were gone. Not because they did anything wrong, not because they failed some test, but because they were unlucky, because the cosmic dice rolled against them. We're in the same position. We've evolved over millions of years, achieved consciousness and technology, built a global civilization, and we're just as vulnerable to asteroid impacts as the dinosaurs were. More vulnerable in some ways, because our civilization depends on infrastructure that's fragile, that can't survive major disruptions. But we have one advantage the dinosaurs didn't: awareness. We know about asteroids. We understand the threat. We can, in principle, detect and deflect them. Whether we actually do so is a choice, a collective choice about resource allocation, about priorities, about how seriously we take low probability but high consequence risks. So far, we're choosing to invest some effort but not enough. We're acknowledging the threat but not fully preparing for it. We're hoping we get lucky, that no large asteroid hits in the near future, that we have time to develop better detection and deflection capabilities before we need them. That's a gamble, maybe a reasonable gamble, given that the probability of impact in any given year is low. But it's still a gamble, and the stakes are civilization itself. Let's drift toward contemplation now, toward accepting asteroid impacts not as an immediate threat, but as part of the larger context of living on a planet in a solar system. Asteroids are debris, leftover material from the solar system's formation, too scattered to coalesce into planets, orbiting in the spaces between worlds. Most will orbit indefinitely, harmless. Some will collide with planets or fall into the sun, and some will hit Earth. This is natural. This is how solar systems work. It's been happening for billions of years, and will continue for billions more. We're not being targeted or punished. We're just in a cosmic environment that includes occasional impacts. The same processes that created the threat also created us, the asteroid. The bombard Earth delivered water and organic molecules in the early solar system, contributing to the conditions that allowed life to emerge. The impacts that caused mass extinctions also opened ecological niches, allowing new forms of life to evolve and diversify. The impact that killed the dinosaurs cleared the way for mammals to diversify and eventually for humans to evolve. Without that impact, intelligent life on Earth might never have arisen, or might have taken very different forms. So asteroid impacts are both threat and opportunity, both destroyer and creator, both ending and beginning. They're part of the cycle of creation and destruction that characterizes planetary evolution. Understanding this doesn't make the threat less real. An asteroid impact tomorrow would still kill billions, would still end technological civilization. But it places the threat in context. makes it part of the natural history of Earth rather than an aberration or attack. We can work to prevent impacts. We should work to prevent them. But we should also accept that we live in a universe where rocks fall from the sky, where planets are bombarded by debris, where extinction-level events are part of the long-term pattern. This acceptance isn't fatalism, it's realism. It's seeing clearly what we face and choosing to respond with effort and preparation, rather than denial or despair. The rocks are out there. They're orbiting. Some will hit Earth eventually. We can reduce the probability, can detect and deflect many of them, but we can't eliminate the risk entirely, so we live with it, with awareness but not obsession, with preparation but not paralysis, with clear eyes and full hearts, knowing the danger, working to mitigate it, and living fully regardless. Let's move into the deepest contemplation now, into the space where the fear of asteroid impacts transforms into acceptance, where the threat becomes part of the larger understanding of what it means to exist on a planet, in a solar system, in a universe governed by gravity and momentum. We've spent time with asteroid impacts. We've examined the physics, walked through the consequences, contemplated both the immediate horror and the long-term survival scenarios. We've felt appropriate fear, acknowledged genuine vulnerability, recognized that our civilization exists in a shooting gallery, and that eventually, inevitably, we'll be hit. Now it's time to integrate this knowledge, to find peace not through denial but through perspective, through understanding our place in a cosmos where such events are natural, expected, part of the pattern. Start with this fundamental recognition. Earth has always been bombarded. From the moment it formed 4.5 billion years ago, it's been accumulating mass through impacts. Early Earth was shaped by countless collisions, small ones adding material, large ones melting the surface, one enormous impact creating the moon. The bombardment continues today, just at a lower rate. Every day, tons of material from space fall to Earth. Most of it is dust, burning up harmlessly in the atmosphere. Some are small meteorites that reach the surface, and occasionally, rarely but inevitably, something large hits. This is not abnormal. This is not a malfunction of the solar system. This is standard planetary evolution, the way rocky worlds grow and change over billions of years. You exist because of impacts. The water in your body probably came from comets that struck early Earth. The organic molecules that became the building blocks of life might have been delivered by asteroids. The extinction events that cleared ecological niches allowed your evolutionary ancestors to diversify and thrive. Impacts giveth, and impacts taketh away. They're creative and destructive, both problem and solution, both threat and opportunity. The universe doesn't owe you a stable environment. It doesn't promise that the conditions allowing for your existence will persist indefinitely. It just is, following physical law, producing environments where life can emerge when conditions allow, and eliminating those environments when impacts or other catastrophes occur. This is not cruelty. It's not indifference in the moral sense, because the universe isn't a moral agent. It's just how things are, how they've always been, how they'll continue to be. And in that how things are, you find yourself conscious, aware, able to understand the threats you face even when you can't eliminate them entirely. Let's think about the difference between individual and civilizational timescales, because it matters to how we think about asteroid threats. On individual timescales, your lifetime, your children's lifetimes, the probability of a major asteroid impact is extremely low. You're far more likely to die from heart disease, cancer, accident, or any of countless other causes than from an asteroid. So on a personal level, asteroid impacts are not worth significant worry. They're background risk, something to be aware of but not to dwell on, not to let affect your daily decisions or emotional state. But on civilizational timescales, centuries, millennia, millions of years, asteroid impacts are certainties. not possibilities, not probabilities, certainties. The only question is when, not if. A civilization that lasts 10,000 years faces essentially zero risk from extinction-level impacts. A civilization that lasts 1,000,000 years will almost certainly experience at least one major impact. A civilization that lasts 100 million years will face multiple extinction-level events. This means that if humanity wants to persist for geological timescales, we need to solve the asteroid problem. We need robust detection, reliable deflection, and the organizational capacity to maintain both across centuries or millennia. We haven't solved this yet. We've made a start, but only a start, and whether we'll develop the long-term thinking, the sustained commitment, the generational continuity needed to truly protect ourselves remains an open question. Short-term thinking says, the risk this year is low, so why invest heavily in prevention? Long-term thinking says, the risk over millennia is high, so we must invest now to protect future generations. Which perspective wins determines whether humanity becomes a long-lived civilization or a brief anomaly in Earth's history, existing for a geological eye blink before an asteroid resets the planetary ecosystem and something else gets a chance to evolve. Let's talk about meaning again, but from a different angle than before. If an asteroid impact tomorrow ended human civilization, would our existence have mattered? Would the art we've created, the knowledge we've accumulated, the experiences we've had, would any of it have cosmic significance? The honest answer is, probably not. The universe is vast. Our existence is brief. Our influence is limited to one small planet around, one ordinary star. In the grand cosmic story, we're barely a footnote. But cosmic significance isn't the only kind of significance. There's also local significance, immediate significance, the meaning that exists in the experience itself, rather than in some imagined permanent record. You matter to yourself. You matter to the people who know you. Your experiences are real. Your consciousness is real. Your suffering and joy are real. And that reality doesn't depend on whether anyone remembers it 1,000,000 years from now. An asteroid can end your future. It can prevent your descendants from existing. It can erase the civilizations you've built. But it can't erase the fact that you existed, that consciousness occurred here, that for a brief time the universe knew itself through billions of human minds, that knowing is complete in each moment. It doesn't require continuation to be valuable. It just needs to happen, which it has, which it is right now as you listen to these words and think about what they mean. The asteroid threat doesn't diminish this. It just reminds you that the knowing is temporary, that consciousness is fragile, that existence is contingent on conditions that aren't guaranteed to persist. But temporary, fragile, and contingent are true of everything. Your individual consciousness is temporary. Human civilization is temporary. Earth's habitability is temporary. Even the sun is temporary, eventually expanding into a red giant and consuming the inner planets. Nothing lasts forever, everything ends. The only question is when and how. Asteroids are one possible answer to how. They're a natural, expected, well-understood mechanism by which planetary ecosystems get reset, by which the dominant life forms get replaced, by which evolution gets new opportunities to explore different forms and structures. From a cosmic perspective, from the perspective of life as a phenomenon rather than humans as a species, asteroid impacts aren't catastrophes. They're transitions, endings that are also beginnings, destruction that creates space for creation. This perspective doesn't make the threat less real to you, doesn't make the potential death of billions less tragic, but it places that tragedy in a larger context, makes it part of a pattern that's older than humanity, that will continue after humanity. That's simply how planets work over deep time. Let's think about legacy one more time, about what survives an extinction-level impact. Physical artifacts don't survive. Buildings collapse, burn, erode, books decay, hard drives fail. Everything made by humans crumbles back into the environment over thousands or millions of years. But some things might persist longer. The Voyager spacecraft, already in interstellar space, will drift through the galaxy for billions of years carrying their golden records, messages from humanity to anyone who might find them. There are our longest lasting artifacts, though the odds of anyone finding them are vanishingly small. On Earth, after an impact and recovery, what would future intelligent species find? Geological layers with unusual iridium concentrations indicating impact events, fossilized bones of extinct species. Maybe some of our constructions, heavily eroded, barely recognizable. The Great Pyramids might leave traces. Major cities might create anomalous geological layers of concrete and metal, but they wouldn't find books, wouldn't find databases, wouldn't find the accumulated knowledge of human civilization in any accessible form. They'd find evidence that we existed, that we built things, that we went extinct, but not what we knew, what we thought, what we created culturally, unless we deliberately preserve it, unless we create archives designed to survive impacts, buried deep in geologically stable regions, encoded in durable materials, with instructions for decoding written in multiple languages and symbolic systems. Some efforts like this exist, the Svalbard. Global Seed Vault preserves plant genetic diversity. Various archives preserve cultural knowledge, but they're not designed for post-impact survival, not built to last through years of darkness and cold, not placed to survive mega tsunamis and global firestorms. We could do better. We could create true deep time archives, information preserved in formats that might survive and be discoverable by whatever intelligent species evolves after us. Should we? Is it worth the effort to create messages for potential future intelligences that might never exist, that we'll never meet, that might not care about what we have to say? There's no practical answer. The effort wouldn't benefit us or our immediate descendants. It's purely altruistic toward hypothetical future beings, purely an expression of the desire to say, we were here, we knew things, we want to share what we learned. Some people find meaning in that desire, others don't. Both positions are valid, but the question itself is interesting. What do you want to survive you? What's worth preserving beyond your own lifetime, beyond your species' lifetime, into a future you can't predict or imagine? Let's talk about the present moment again, because it's the ultimate response to all existential threats, including asteroid impacts. Right now, as you listen to these words or read them or think about them, there's no asteroid hitting Earth. The sky is clear of incoming impactors, the planet is stable, life continues. This has been true for your entire life. Every day you've existed, Earth hasn't been hit by an extinction-level asteroid. The threat is real, but it's not immediate. It's not happening now. And now is all you directly experience. The past is memory. The future is imagination. Only now is actual, is present, is the arena where consciousness operates. In this now, you're safe from asteroid impacts. In the next now, and the next, and the next. Probably also safe. The probability of impact in any given moment is infinitesimally small. So while it's wise to be aware of the threat, to support efforts at detection and deflection, to understand the risks we face as a civilization, it's not wise to live in constant fear of something that almost certainly won't happen today. Fear is appropriate for immediate threats, for dangers you can respond to right now. But for long-term, low-probability threats, awareness is better than fear, preparation is better than anxiety, understanding is better than dread. You know about asteroids now. You understand the threat. You've contemplated the consequences, and you can let this knowledge settle into the background, can release the emotional intensity while retaining the intellectual understanding. The asteroids are out there, they're orbiting, eventually one will hit. But probably not today, almost certainly not today. So live today as if you'll have tomorrow, while understanding that tomorrow is never guaranteed, was never guaranteed. Regardless of asteroids or any other threat, this is wisdom, acting on probabilities while accepting uncertainty, planning for the future while being present in the now, taking threats seriously without being paralyzed by them. Let's think about evolution and adaptation one more time, about how life responds to catastrophes like asteroid impacts. When the Chicxulub impactor hit 66 million years ago, it killed the dinosaurs. But it didn't kill everything. Small mammals survived. Birds survived. They're dinosaurs technically, but they made it through. Crocodiles survived. Sharks survived. Many plant species survived as seeds. The survivors weren't necessarily the strongest or the smartest. They were the lucky, the adaptable, the ones whose specific characteristics happened to be suited for surviving impact winter conditions. Small size helped. Smaller bodies need less food, can survive on limited resources. Burrowing helped. Underground shelters provided protection from temperature extremes. Broad diets helped. Generalists survived when specialists whose food sources disappeared went extinct. After the impact, these survivors faced a changed world. Different climate, different ecosystems, different competitive pressures, and they evolved to fill the vacant niches, to exploit the new opportunities. Mammals, which had been small and marginal during the dinosaur era, radiated into enormous diversity. Primates evolved. Eventually humans evolved. And none of this would have happened without the asteroid impact that eliminated the dinosaurs and opened up ecological space. So from an evolutionary perspective, asteroid impacts aren't just destructive, they're also creative, forcing rapid adaptation, creating opportunities for new forms to emerge and thrive. This doesn't make the impacts less tragic from the perspective of the species that go extinct. The dinosaurs didn't benefit from their extinction, they just died. But life as a phenomenon, evolution, as a process, benefited. The biosphere became more diverse over time, explored new forms, achieved new capabilities. And if another major impact occurs, if humanity goes extinct or is drastically reduced, evolution will continue. Something will survive. Something will adapt. Something will eventually diversify and perhaps achieve intelligence again. We're not the end point of evolution. We're one branch among millions, temporarily successful, potentially long-lived if we solve our problems, but not essential to the continuation of life or intelligence on Earth. This is humbling. But it's also liberating. We don't carry the weight of being the universe's only hope for consciousness. We're one expression of consciousness among potentially many, one experiment in awareness that succeeded so far but could fail, and if we fail, the universe will try again through other forms. Let's drift into silence now, into the quiet acceptance that comes when understanding becomes peace, when knowledge of threats settles into its proper place. You know about asteroids. You understand the physics of impacts, the consequences for civilization, the long-term inevitability of being hit again. You've confronted the threat directly, examined it from every angle, felt appropriate concern, and now you can release it. Not forget it. It's part of your knowledge now, but let it settle into the background where it belongs, alongside all the other real but non-immediate threats. The sky is clear above you, has been clear for your entire life, for all of recorded history, for the 66 million years since the last major impact. The bombardment continues, but at a rate that's survivable, that allows civilization to build, that permits life to flourish. Today, the asteroids are far away, following their orbits, not intersecting with Earth's position in space. Tomorrow, probably the same. Next year, next decade, next century, probably also clear. Eventually one will come. Liwa, timescales of millions of years, it's inevitable. But on timescales that matter to your life, to your immediate experience, it's extraordinarily unlikely. So live in the timescale that matters to you. Live in the present. Live in the actual, not the hypothetical. Live in the now that's real rather than the futures that are merely possible. The asteroid threat doesn't define your existence. It's context, not content. It's background, not foreground. It's something to be aware of, to support efforts to address, but not to obsess over, not to let dominate your consciousness. Be at peace with living on a planet in a shooting gallery. Accept that safety is statistical, not absolute. Understand that existence has always been contingent, that you've always been one catastrophe away from ending, and that this knowledge doesn't diminish the value of being alive. The dinosaurs had 165 million years. Not immortality, but a remarkable run. They evolved, diversified, dominated their world, and then an asteroid hit, and their reign ended, and something else got a chance. Maybe humanity will have as long. Maybe we'll do better, we'll spread to other worlds, we'll become robust enough to survive impacts on individual planets. Maybe we'll do worse. We'll end ourselves through war or environmental collapse before any asteroid gets us. We don't know. The future is uncertain. Always has been. Always will be. What we have is now. This moment. This awareness. This breath. This experience of being alive on a planet that's been relatively safe from major impacts for 66 million years and might remain safe for millions more. Sleep now, or wake, or continue your day, carrying this understanding lightly. The rocks are out there, orbiting. We're watching some of them, missing others. Eventually one will come. But not today. Almost certainly not today. And today is enough. Today is real. Today is where you exist, where life happens, where meaning is created. Be here for it, fully, without the weight of hypothetical futures pressing down on the actual present. The asteroid will come when it comes. Until then, and perhaps even then, if you're among the survivors, there's life to be lived, awareness to be experienced, meaning to be created in the brief window between birth and death that's all any conscious being ever has. Live that window, fully, presently, with clear eyes about the threats but without being defined by them. The planet and the consciousness it supports, orbiting together through a solar system full of debris, both vulnerable, both temporary, both extraordinary. Be grateful for the orbit that hasn't yet intersected with catastrophe. Be present for the moments of stability between impacts. Be aware that the bombardment continues, but that space is vast and rocks are small, and most of them miss. This is how you live on a planet in a shooting gallery, with awareness, with preparation where possible, with acceptance of what can't be controlled, and with full engagement in the life you have right now. The stones fall from heaven, have always fallen, will always fall. But between the falls there's time. Time to grow, to learn, to love, to build, to experience what it means to be conscious in a universe that produced consciousness without promising to preserve it. That's enough. That's everything. The sky is clear now. The orbit continues. The consciousness persists. And in that persistence, brief and vulnerable as it is, the universe knows itself, experiences itself, creates meaning from its own existence. You are that knowing, for now, for as long as now lasts, which is always only this moment, which is always sufficient. Rest in that sufficiency, not in false promises of permanent safety, but in the reality of present stability, present awareness, present life. The asteroid's orbit, the planet orbits. You exist in the intersection of these orbits, in the space where matter organized itself into consciousness, where the universe achieved awareness of its own beauty and danger. Be here for that awareness, fully, completely, for as long as the orbits allow. And when they no longer allow, when the paths finally intersect, face it, as all conscious beings must face their endings, with presence, with acceptance, with the knowledge that you existed, that you were aware, that you participated in the extraordinary phenomenon of consciousness. That participation is complete in each moment, doesn't require continuation to be real, it just needs to happen, which it is, which it does, right now. That's the teaching of the asteroids. Everything ends, everything is vulnerable, everything is temporary, and everything, in its moment, is real. Be real. Be present. Be here, for as long as here is possible. which is now, which is always enough,